So yeah, we will be, the multiplication principle you have already seen, that when we are having three boxes and we are having five letters, six letters, and we have to make the code of three at a time. That time we were doing for first one how many possibilities, space filling, exactly space filling related to that we have done few questions, right?
Yes, ma'am.
That time we were doing multiplications, that for first one five possibilities are there, for second box four possibilities are there, for third box three possibilities are there. So that time we were applying multiplication principle. If there are m ways, for shirts and trousers also we have discussed, if there are m ways to wear the shirt, if there are n ways to wear the trousers, then m into n are the total number of ways we will be getting, right? that's that one is multiplication principle. And what is addition principle? So addition principle says, let's say this is city A and this is city B. So from city A to city B, suppose there are few options to reach city B. So either we can go by bus, or we can go by bike, or we can go by car. So or whatever we are saying, no, either we can go by bus, or we can go by train, or we can go by car. If this type of options are there while solving any question, for this or we use the addition sign. Okay. So whenever we are having options like this one, that either this can be chosen or this can be chosen, so for or we use addition sign. Okay. Now circular permutation. Before moving to circular permutation, we will be solving questions from permutations. So the space filling question which we used to do just by using the concept, here we are going to use the formula to do it. And what the formula says now, you are having the knowledge about what is factorial, how to deal with the factorial. So we are going to discuss permutation with the help of formula. Without formula also we were finding it by with the use of space filling concept. But today we are going to discuss it by using the formulas. So the formula, just let me open the book and let me take out few questions from there. So if we are selecting R object out of N object, so the formula for that NPR is equals to N factorial by N minus R factorial. This R value must be like greater or equals to 0 or less, or maximum R can be N. Okay. So if out of five objects, if you are selecting three at a time, or out of five alphabet, if you are selecting two at a time, then 5p2, this way we can find. And this you can select out of 5, you can select 2 at a time, you can select 3 at a time, you can select 4 at a time, you can select 5 at a time. More than 5 you can't select, right?
Yes, ma'am.
That's why we say that R is always greater or equals to 0 and less or equals to n. So maximum R can be n only, it will not exceed n. This is the formula for finding the permutation. Previously, whatever we were doing for the space filling question, same type of question we are going to do by using this, using this formula. So let's apply this formula. One thing you must know, that 1 factorial is 1 and 0 factorial is also 1. Okay, so let's do few questions from here. Number 1 question is, how many 3-digit number can be formed by using the digits 1 to 9? If no, and this formula is only applicable when you are having distinct object, distinct numbers. Okay, if no digit is repeated. So this one is the question, how many 3-digit number can be formed by using digits 1 to 9? So when we are having digits 1 to 9, 1, 2, 3, 4, just a second. Can you see the screen?
Yes, ma'am.
1 to 9 means what? We are having 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the numbers we are having, and we have to make 3-digit number. So previously we have done this type of question by using the space filling concept. Yes or no?
Yes, ma'am.
Here we will be using this concept of the formula for permutations. That is selecting 3 out of 9. So 9p3, and the formula says for npr the formula is n factorial by n minus r factorial. So let's use that. 9 factorial by 9 minus 3 factorial, which will be 9 factorial by 6 factorial. Yes or no?
Yes, ma'am.
And previous day we have already discussed the concept of solving this factorial notation, that how to solve it easily in a simple way. So we can write it as a 9 into 8 into 7 into 6 factorial. Can I write?
Yes, ma'am.
Divided by 6 factorial, 6 factorial, 6 factorial gone. And now we can do the multiplication of 9 into 8 into 7 to get the answer. Yes or no?
Yes, ma'am.
Got it?
Yes, ma'am.
So previously also we have done this type of question, Lena. Please don't get confused. Nine digits we are having, and we have to take 3 at a time. So for the first one, 9 options are there. For the second one, 8 options are there. For the third one, 7 options are there. The same thing we used to do multiplication and used to get the answer. Same thing we are getting with the help of the formula of permutation. Okay.
Okay, ma'am.
So in exam, you can do it anyway. But if it says that use the formula of permutation, then we are supposed to use this formula. Okay.
Okay, ma'am.
Let's continue. So the next question says, how many 4-digit number are there with no digit repeated? Can you tell me? No digit repeated. Okay, we have to be careful with that. Can you tell me how to proceed over here? Yes, Lena? How many digits we are having total?
4.
4-digit number we have to make. Out of
Yes, ma'am.
how many digits? We are having digit 0. We are having digits 1, 2, 3, 4, 5, 6, 7, 8, 9. All the digits, like all the numbers in mathematics, a very larger number or a very smaller number, every number, while making any number, we are using only these digits, yes or no?
Yes, ma'am.
Apart from this, there is no other digit which can make a number, right? Whatever number you say, 1 crore, you say 1 million, you say 1 billion, you say 2 billion, 3 billion, 25, 46, whatever you say, every number is having the combination of these digits only. So keep in mind, whenever nothing is given information regarding the total number of digits, we must know that in mathematics we are having only this digit, and every number is just the combination of these digits. Okay, so we are having 0, 1. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 digits we are having. Here we have to make 4-digit number, but we cannot use 0 in front, right?
Yes, ma'am.
If you have to make 4-digit number, 1, 2, 3, here we cannot use 0. Because if we will use 0 over here, then that will be 3-digit number only. And we want to make 4-digit number. For the first one, how many choices we are having? Only 9 choices. Yes or no?
Yes, ma'am.
So for the first one, from 9 we have to take 1, permutation of 1, or directly 9p1. If you will if you will calculate it, 9p1, it will be n factorial by n minus r factorial. That means 9 factorial by 8 factorial. That is just 9 only. Because 9 factorial, you will be able to write it as 9 into 8 factorial. 8 factorial will just cancel out each other and you will be having only 9. So either you write 9p1 or you write directly 9. Both are correct. Okay.
Okay, ma'am.
Now, rest 3 places are there, and in this chapter, I want to stick to the formula, okay, rather than a space filling, so that you will get used to the formula also. So how many places now we are having? So we are having 1, 2, 3 places we are having which needs to be filled. And how many numbers, how many this digits we are having? So 1 digit we have already used. Still we are having out of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From this 10, 1 has been used. Still 9 is left. So I am going to write that permutation of getting 4-digit number. Since it says no digit has to be repeated, that's why we are applying this concept. So first is 9 or 9p1 you can write, and the remaining is from 9 we have to select 3 at a time. Okay, let's do the calculation. So 9 is there, 9 factorial by 9 minus 3 factorial. 9 into 9 factorial by again 6 factorial, which I have shown you how to calculate it. 9 into 8 into 7 into now 6 into 5. Everything is just making it 6 factorial by 6 factorial. Is it clear to you, Lina, how we are breaking it?
Yes, ma'am.
So now we will just cancel it out and we will do the multiplication of all of them to get the answer. Okay, let's get back to the question. It says that how many 4-digit number are there with no digits repeated. So this, whatever you will be getting from here, that many 4-digit numbers are there where the digits are not repeated. If you will apply logic, then you must be thinking 4-digit numbers are 1000, 4-digit numbers are 1001, right? But here, can you see the digits are getting repeated?
Yes, ma'am.
That's why we are not applying the logic, we are using the concept of permutations. Okay, to reach the answer. The next question says, how many 3 digits even number can be made using the digits 1, 2, 3, 4, 5, 6, 7 if no digit is repeated. How many 3-digit even number can be made using this digit? Any idea how to proceed here? 3-digit, obviously even number we have to consider with this one. Yes, Lena, what will be the permutation? Any idea? Whatever you are thinking, just tell me.
There should be either 2, 4, or 6 in the units place.
Perfect. So 3 choices we are having for the unit place. What about the remaining one? You are on the correct, right track. Please continue. 3 choices we are having for the here. Now we have to fill 2 places, right?
Yes, ma'am.
And how many digits are there still after using 1 over here? If we will be using 1 digit over here from the above one, how many digit will be remaining, Lina? 1,
6.
2, 4, 5, 6, 7. 6 will be remaining. From this 6, we have to fill 2 places, yes or no?
Yes, ma'am.
Getting clear? Is it clear?
Yes, ma'am.
Perfect. Okay, now we just need to calculate it. So 6 factorial by 6 minus 2 factorial into 3. So 6 factorial divided by 4 factorial into 3, which can be written as 6 into 5 into 4 factorial by 4 factorial into 3. 4 factorial gone. Please solve it like this only, like by cancelling factorials and everything, and then we can simplify it further. Okay,
Okay, ma'am.
let's continue. Find the number of 4-digit numbers that can be formed using digits 1, 2, 3, 4, 5 if no digit is repeated. How many of this will be even? So how to proceed here? Find the number of 4-digit number that can be formed using this digit. How many digits we are having? 1, 2, 3, 4, 5. 5 digits we are having and we have to make 4-digit number if no digit is repeated. That's it. Second part is also there. We will be thinking about that. But first, the first part. So out of 5, we have to make 4 at a time. We have to take 4 at a time. Yes or no?
Yes, ma'am.
If no digit is repeated, that's it. We will be using the formula and we will be getting how many possibilities are there, how many permutations are there. Now the next part is asking how many of these will be even. From these, how many will be even? So just like the previous one, even means the unit place has to be even number. Then only we can say that we are having a even. Okay. So unit place can be filled with either 2 or 4. Two choices are there for the unit place. 4 digits numbers are there. 1, 2. For two choices are there for the unit place. Two choices are there, but obviously we have used one from this two. Now 1, 2, 3, 4, 5. 5 are there. One has been used. 4 is remaining and we have to still fill 3 places. So out of 4, we have to fill 3 places. Okay? Is it getting clear, Lina?
Yes, ma'am.
Let's move to the next one because this was exactly same like the previous question. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? So from a committee of 8 person, in how many ways can we choose a chairman and a vice chairman? Assuming one person will be holding a one position only, and again no repetition and all. So how to find the permutations? Yes, Lena.
It will be 8 P2.
Perfect. It will be 8p2. Just a second. What happened? Can you see the screen?
Yes, ma'am.
It will be just 8p2 because basically out of 8 we are selecting 2 at a time and both are distinct. So obviously 8p2 and we will be getting the result. We will be getting the permutation of selecting a chairman and a vice chairman. Let's move to the next one. Next one is a few permutation related question where you have to just solve the where you just have to solve the factorial notations and all. So if you will be comfortable with the factorial notation, those questions are very simple. I'm leaving it for you. Do it and do let me know whether you are able to do it or not. Okay, I'm moving to the next one which says how many word with or without meaning can be formed using the letter of the word equation using each letter exactly one. So equation we are having. Now it says how many word with or without meaning can be formed using all the letter while finding the permutation. While using the formula for permutation, I said to you that R can be maximum is equals to P, right? So here out of 1, 2, 3, 4, 5, 6, 7, 8, out of 8 letters, out of 8 alphabets, we have to use all the 8 to make all proper permutations. Okay, so 8p8, right?
Yes, ma'am.
If we will be solving it, it will be 8 factorial divided by n minus r. That means 8 minus 8 factorial. Now only I said to you that 0 factorial is nothing but 1. So 8 factorial by 0 factorial. That will be only, so we just have to do the calculation of 8 factorial. Okay. That means 8
Okay,
into
ma'am.
7 into 6 into 5 into 4 into 3 into 2 into 1. This is what we have to do the calculation to get the possibility of getting using all the alphabets from this word equation. So yes, for this one, most of the time you will be seeing that equation is there or any word is there and we are just using whatever is the number of like letters. We are just taking 7 factorial, 8 factorial directly. Why we are taking so? Because this is what we are getting from the formula only, right?
Yes, ma'am.
Now the next one is the same question which says how many word with or without meaning can be made from the letter of the word Monday, assuming no letter is repeated. So Monday is there. The first case is saying 4 letters are used at a time. 4 letters used at a time. How many total letters are there? 1, 2, 3, 4, 5, 6. Out of 6, we are using 4 at a time. So this will be the permutation, right?
Yes, ma'am.
The next part says all letters are used at a time. All letters are used. Whenever all letters are used, you must be seeing the example or the teacher. They just take 6 factorial. From where this 6 factorial came, it will come out when you will take 6p6. All are used. Okay, and all are distinct, obviously. Okay,
Okay, ma'am.
this will give you this one. So either you are writing 6 factorial directly or you are writing 6p6, then you will land at 6 factorial only and then you just have to do the calculation. Clear?
Yes, ma'am.
Next one is all letters are used but first letter is a vowel. we are having Monday. How many vowels are there?
2.
Two. O and A, right?
Yes, ma'am.
So two vowels are there and first letter has to be vowel. So we are making 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. First has to be vowel. So two selection are possible. Now for the remaining one, we will be using again the formula for permutation, which is how many is the remaining after using one. So 5 is remaining, right?
Yes, ma'am.
From the 6, we have used one of the vowel for the first place. So 5 is remaining, right?
Yes, ma'am.
From this 5, we have to fill 1, 2, 3, 4, 5 places only. So 5p5, either you can write like this or directly you can write like 2 times 5 factorial and then you can do the calculation. Okay,
Okay, ma'am.
next one. In how many way distinct permutation of the letter, let me write it, the letter is in how many ways of the distinct permutation of the letter this Mississippi do the four eyes not come together? Okay, we have to say in how many way, how to find the permutation so that four I from here will not come together. How to do that? Let's see how many repetitions are there. 1 I, 2 I, 3 I, 4 I. Four I's are there. How many S is there? 1,
4.
2, 3, 4. Four S is there. How many P is there?
2.
1, 2, 2p is there. Anything more which is repeating itself over here?
No.
No. So at first let's find the permutation of arranging all of them. Okay, in a different possible way. So how many letters are there in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total 11 letters are there, right?
Yes, ma'am.
Here we are having the repetition. Previously we were not having the repetition. Whenever we are having the repetition, we have to write it in the denominator, whatever repetition is there. Okay, so here we are having 4i, 4s, 2p. So here we are having 4i, 4s, 2p. Whenever we are having repetition like that, there is a particular formula for that, and the formula says whatever we are having as a repetition, we need to write it in the denominator. So 4i, 4s, 2p. Are you getting it? Why I have
Yes, ma'am.
written 11 factorial in the numerator? Now only I told you, whenever we will be arranging, like six letters are there, and all six, if we are arranging, the permutation will be 6p6, and which, by using which, you will land at 6 factorial only, right?
Yes, ma'am.
Here we are arranging all the 11 of them. Okay. So if we will be having 11p11, that will give us 11 factorial only, right?
Yes, ma'am.
So that's why I have written 11 factorial in the numerator, and in the denominator, whatever repetition is there, that we have to write it like this. Whenever there is a repetition. And if there is no repetition, no need to write this. Okay.
Okay.
So permutation of arranging all of them. This will be the permutation of arranging all of them. Now you must be thinking here, it's not asking about the permutation of arranging all of them. It's asking about the four I do not come together. So what we can do here, first we will be finding the permutation of arranging, possibility of arranging all of them. After that, we will be finding the possibility of arranging when all I comes together. Okay, what are the ways in which all i's are coming together? I, the this alphabet I. Now from all of them, if you will subtract all I coming together, then you will end up having all four I not coming together. Yes or no?
Yes, ma'am.
So that's what we are going to do it over here. First, permutation of arranging all letter of the word Mississippi. Okay, permutation of arranging all letters of the word this is the permutation. Now all I coming together, permutation of getting all I together. Now when we will be taking all the I together, then it means we are going to make a packet of I. Okay, we will be making a packet of I, and that is a single unit for us. So I am going to keep all I together over here. 1, 2, 3, 4. This 4 I, we are going to just pack it inside a packet, and nobody knows that 4 I's are there. Whoever will see this packet, they will think, okay, one object is there, one letter is there, one letter is there. Just like M, just like S, just like another S, it's this total is a one unit. Okay.
Um,
So let's see how many total, now what is the total number of letters we are having. So M is there, I we have kept it as a single unit, 2 S is there, one more, like S is there, one more S is there, 4 S are there, 2 P are there. So let's count it, how many total. One, this is one packet and one thing, one unit, one object for us. Two, 3, 4, 5, 6, 7, 8. So total 8 letters are there, right? Are you getting it? We have just
um,
hidden all I in a packet. All are sitting together and nobody knows about that. So whoever is counting, they are counting it as a single unit. So 1, 2, 3, 4, 5, 6, 7, 8. Can I say total 8 units are there? And we have to arrange all of them.
Yes, ma'am.
Out here, what is the repetition? So whoever will see, they will say that okay, 4s are there and 2p's are there. So repetition is 4s and 2p only, not I. Okay. So 4 factorial into 2 factorial. This will give all I sitting together. The permutation of getting all I, the number of possible way where all I are sitting together. Getting it, Lina?
Yes, ma'am.
And when you will do the subtraction of the like below one from the above one, you will get the final permutation. Let's do it. So let's calculate it above one, above only. So we are having 11 factorial. So let's write it 11 into the minimum we can reach to 4, so that 4 can be cancelled. No other way is there. So 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial, 4 factorial, 2 factorial. One of the 4 factorial will just cancel out. Another 4 factorial and 2 factorial. Anyway, we have to expand it. So let's expand it. We'll be having 11, 10, 9, 8, 7, 6, 5, and in the denominator we are having 4 times 3 times 2 times 1. It's just okay, times 2. Let's cancel them out. So we are having, so let's cancel them out. So we are having 4 2 times 8 and 8 gone. Okay, 3 2 times 6 and 6 gone. Please do the calculation and tell me what exactly are we getting. We are having 11, 10, 9, 7, 5. Can you see it, Lina? Okay, just leave it. Okay, whatever you will be getting from here after doing the calculation, again you have to do the calculation over here, and then you have to subtract from the above one, you have to subtract the below one. Will you be able to continue from here?
Yes, ma'am.
Have you got the concept? 4i not
Yes,
sitting
ma'am.
together means let's take out the total probability. Then let's take out the permutations. Okay, let's take out the total number of ways of arranging it. Then take out when the number of possible way when we are having 4 i's together. And once we will be subtracting it from the total, we will be getting the remaining one where the 4 i's are not together, right?
Yes, ma'am.
Let's continue. So from now only, Lina, just keep on preparing this chapter. Like I am discussing the chapter with you, you will go and give the assessment. There you will feel whatever is not clear to you. Please do let me know, and we will be discussing those concepts. And then you are giving the test, you are doing the homework, and this way the whole chapter like is getting prepared. When exam will come, you will be sure like you will be assured that this chapter is already prepared, right?
Yes, ma'am.
So this way, please do a preparation of each and every chapters seriously. Okay, so let's continue with the like now only once we will be discussing everything like in today's class, whatever we are discussing, please give the assessment and do let me know like everything was correct or not. Okay.
Okay, ma'am.
Okay, so let's continue with the next question. So the next question we are having, in how many way can the letter of word permutations be arranged if permutations? Here also you can see few repetitions are there. If words starts with P and end with S. So let's see how many letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, total 12 letters are there. Yes or no?
Yes, ma'am.
Then which one is repeating itself? P. No other P is there. E. No other E is there. R. No other R is there. M. No other M. U is not there. A. A is there. T is there. Can you see? Two T's are there.
Yes, ma'am.
Anything else?
No, ma'am.
Nothing else. Let's write the permutation. So it says P and S. These two places are fixed. The word is starting with P and ending with S. So out of 12, we have already used 2, right?
Yes, ma'am.
Remaining 10 places we need to fill by using 10 letters. So 10 factorial directly we can write, 10p, 10 is 10 factorial only. And how many repetitions are there? That too we have to write carefully. That is 2 t's are there. So divided by 2 factorial. Is it clear?
Yes, ma'am.
Let's do the next one, which says vowels are all together. Just a second. The next one says that vowels are all together. Now only when we have done the case where all eyes are together, here also we will make the packet of vowel and will keep it all at one place by treating it as a one unit. Now let's see how many vowels are there. How many vowels are there, Lina? E, U, A, I, O. Anything else?
No.
How many total?
5.
Total 5 vowels are there from this 12 uh, alphabets. 5 are vowels, right?
Yes, ma'am.
This all 5 you will make it a packet and you will keep it at one place. Okay, like all the vowels are here rather than 5, all vowels are, shall I write? How many vowels are there? 5 vowels out of 12. So remaining are 12
7.
minus 5. So remaining are 7. Okay, we have to arrange this 7 and this packet of vowel. That means 8. Total 8 we have to arrange. Yes or no?
Yes, ma'am.
So total 8 factorial divided by, if there is any repetition, we have to consider that. So repetition is there for T. So yes, we will be taking the repetition. That is 2 factorial, right?
Yes, ma'am.
This is the permutation of getting all the vowels together. Let's do the next one. Is it clear, Lina?
Yes, ma'am.
Let's do the next one. There are always four letters in between P and S. So P and S. 1, 2, 3, 4. It can be like this, right? How many total are
Yes,
there?
ma'am.
12. So 1, 2, 3, 4, 5, 6. Let me make 12. Okay, it will be like this. I'm going to write all the possibilities over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, let's write it. So P can be here and 1, 2, 3, 4 places S can be here. Right?
Yes, ma'am.
Let me write the other possibilities. P can be here and 1, 2, 3, 4 S can be here. Right?
Yes, ma'am.
P can be here and 1, 2, 3, 4 S can be here. So three possibilities we have written for the above one, right?
Yes, ma'am.
Let's do the same for the below one. So I'm saying I'm saying that we have taken P at the third place. P can be at fourth place, and 1, 2, 3, 4 S can be here, right?
Yes, ma'am.
Similarly, P can be at fifth place here, and 1, 2, 3, 4 S can be here, or P can be at sixth place, and 1, 2, 3, 4 S can be here, and one more possibility will be here. Can you see where P will
Yes,
be
ma'am.
here and S will be here? So total, this has given me three possibility. This has given me three possibility, and here I am having one possibility. So total, I am having seven possibility. But when we will reverse the places of P and S, seven more possibility will come out. Yes or no?
Yes, ma'am.
So can I say total 14 possibility we will be having? 7 from here
Yes, ma'am.
and 7 more. Why 7 more? It can also be the case, no? Where it can also be the case where S is here and P is here, right?
Yes, ma'am.
Same for the other ones. So total 14 different possibilities we are having when we are arranging the gap between P and S 4. So total 14 possibilities we are having. Now how many letters we are arranging? So when P and S is fixed, how many letters we are arranging? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 letters we are arranging, right? The
Yes, ma'am.
remaining 10, right? Let's write it. So total remaining 10 places we are filling, 10 factorial, because we are having 10 places and 10 letters. And how many letters are repeating itself over here in this word? I have not
2.
written the word. 2. Permutations 2. So divided by 2. And this will give us the possibility or number of way of getting 4 letters in between P and S. Right, Lena?
Yes, ma'am.
Have you understood it? How we
Yes,
are
ma'am.
getting the cases, how this 14 cases came out, that is the main thing. And apart from that, we are not doing anything else. We are just filling the 10 places with the help of 10 letters. And obviously when repetition is there, we write it in the denominator. Clear?
Yes, ma'am.
Let's move to the next concept. So this is how we have just completed the concept of permutations. You will be able to solve the, you can solve it by space filling method, you can solve it by formula method. Here totally we have used formula. Whatever seems convenient to you, you can use any method. Okay, now we will be discussing about circular permutation. What is this circular permutation? So circular permutation means, suppose we are having a circle and 3 people are sitting over here. Here A is there, here B is there, and here C is there. And they are just sitting in such a space, no, where everything is, you can say, everything is just white. This table is white, the walls are white. They don't have any knowledge about the direction. They don't have anything like which direction they are facing, which direction they are sitting. Nothing is there, everything is just white over there. Okay, and in such a place a table is there, that too is white, let's say, and the people are sitting like that. Why I'm saying white, because once they are sitting, they don't have any knowledge about the directions and all. Okay,
Okay.
now let's say they are changing their places. So A is here, B is here, C is here. Now I'm saying that A just shifted one place, came here. B just shifted one place, came here, and C just shifted one place, came here. Okay, now they are again shifting their places. So here A again shifted one place, B shifted one place, and C shifted one place. Like this. Okay, so from the first case, they gone to second case, they gone to third case. Now if anybody is asking A, if A is just A just faces inward towards the, this direction is like this direction is like this, and this direction is like this. Similarly here the direction is like this. They are facing like inside part of the table. Okay, not outward. They are facing like this. So if I will ask, in the first case, A is saying B is on my left and C is on my right. Can you see it?
Yes, ma'am.
So B is towards my left and C is towards my right. In the second case, again A is saying B is towards my left and C is towards my right. Can you see?
Yes, ma'am.
And in the third case also A is saying B is towards my left and C is towards my right. Can you see?
Yes, ma'am.
So all the cases are same for A, because A doesn't have any knowledge about the direction or anything in that room. And whenever all of sudden anyone is asking, tell me where is B, where is C, so every time he is saying the same thing and forgetting about the previous case. And he is saying, I have not changed the place, still I am at the same place only. B is here, C is here. B is here, C is there. Okay, so according to A or according to B or according to C, they are not changing their place. Previously also, whatever was left and right, whoever was on the left, whoever was on the right, same. Second case, same people are having left and right, so they are thinking that we have not changed the place. Maybe we can just revolve the table, and if that is the that is their place, so they are thinking that they have not changed the place. These all three are the same case. Okay, when we are having circular permutation, because left and right people are not changing, right? So for
Yes,
circular
ma'am.
permutation, we are taking all these three cases as one case only. Because if you will ask B will again say the whatever he is going to say for the first case. For the second and third case, he will be saying the same thing, and eventually he will be saying, I have not changed my place. This is the same sitting arrangement. Okay,
Okay.
so here, while finding this circular permutation, what we do, we are arranging three people, so we take 3 divided by 3, because 3 cases are there and all the 3 cases are exactly same. Okay, that's why we are dividing. Whenever I was exactly same, t 2 t was there, 2 p was there, whatever was there, we used to divide it by that. Here also we will be dividing it by that. Okay, or you can say this is the formula for that, that whenever we have to find n factorial for circular permutation, we take n factorial, n factorial divided by n. Is it clear?
Um,
You can see one more case. This is the first case. Case 1. And the for case 1, we are having the formula to find n factorial. That is, whenever we are having a circular arrangement like this, then n factorial will be n factorial by n. Okay, for circular arrangement. And this is applicable when anticlockwise and clockwise arrangement are different. Why I'm saying anti-clockwise and clockwise arrangement are different? Now let's say this is the arrangement. 1, 2, 3. Here is A, here is B, here is C. Okay. Let me take different way. Suppose here is C, here is B. Now if they will change, just like the previous case, if they will change the places in cyclic manner, so suppose C gone over there, A gone over here, and B gone over here. Suppose then C came over here, A gone over here, B gone over here. Now if you will ask A, who is towards your left, A will say C is towards my left, right? And B
yes,
is
ma'am.
towards the right, right? Again, if you will ask A in the second case here, second, who is towards your left, again C is there towards the left and B is towards the right. Again, C is towards the left and B is towards the right. Can you see all the 3 cases are again the same case?
Yes.
So the previous one was different. Here we are having different case. So this way we will be getting like three cases will come out as a same. Even if they will rotate their place, still they will be in the confusion that they are sitting on the same place, because the person beside on the left of a, on the right of a is same. For that only we use this formula for finding n factorial. We take the formula n factorial by n. And when we are talking about case 2, I'm just giving an example to make it more clear to you, don't worry. So for case 2, the formula is n factorial will be n minus 1 factorial by 2. Why we are using two formulas, when we will be using the first one and when the second one? Let me write the example. In how many ways 4 boy can be arranged on a circular table? So 4 boys we are arranging on a circular table. 4 factorial we have to find, no? But we'll be using 4 factorial divided by 4. Okay? Whenever we are
Yes.
sitting for circular table, circular permutation, this is the formula, right, Lena? N factorial is n factorial by n, right?
Yes, ma'am.
So this formula we need to use over here. From where this formula came out? Just by the concept that few, like 4 cases will be there where they'll be thinking that they are on the same places and all. Okay. Now where we will be using the second case? How many garlands can be made using 4 different flowers? Here we will be using the second formula. Why? Because it's the case of garland. Let me show you one garland.